One of mankind's biggest questions is, are we alone in this universe? We have always been very curious. So could there be some form of life out there? Starting closer to home, could there be life on Mars? It is a challenge that will not go away. So where is Mars? Well, it's the fourth planet away from the Sun. It is much colder than the Earth and seen to be quite barren. Despite this, could there have been life on Mars? The big question. The nearer planets to the Sun, Mercury and Venus, are very hot, so any water at this temperature would have boiled away a long time ago. There would be no possibility of life as we know it without water. This is the story of Beagle II and its attempt to find life on Mars. Beagle II was designed to detect water, methane and organics on the surface of Mars. That is, to detect the possibility of life there. This picture shows how it should have operated. So how did Beagle II come about? Here we must turn to Professor Colin Pillinger of the Open University. Professor Pillinger had analysed the Apollo moon samples and became a recognised world expert in the 1970s. Then he analysed meteorites that were discovered in Antarctica. They contain carbons, carbonates and methane, important elements of life. There was a strong indication that they were from Mars. But were they? There was only one way to tell. That was to get a sample from the Martian surface itself and test it. The idea for a Mars lander was born. In 1996, Colin Pillinger heard that the European Space Agency, ESA, were considering a satellite mission to Mars. It was just the thing for his Mars lander. His lander could hitch a lift on the satellite, hop off from Mars and go down to the Martian surface. He was determined to get a lander on the ESA Mars mission. There was no stopping him now. 3 years later, in 1999, ESA finally made the decision for a satellite mission to Mars, to get there in 2003. It was to be called Mars Express. Mars was closest to the Earth for 60,000 years. It was to examine the Martian atmosphere, to take high-resolution photos of the surface, and to do a radio science experiment. It was also to perform a subsurface radar test called MARSIS, with startling results, as we see later. To get his lander on Mars, Colin Pillinger proposed a Mars rover of 110 kilograms to ESA, to be carried on the Mars Express satellite. ESA were not keen. It would interfere with the Mars Express mission itself. But Colin Pillinger badgered ESA, and they reluctantly agreed in 2000, but at a weight of only 69 kilograms, not the 110 kilograms. Colin Pillinger then revised the rover to be a lander only, a probe but with no wheels. It was to be called Beagle II, named after Darwin's ship to the Galapagos, HMS Beagle, in 1830. Both were voyages of discovery. However, ESA made 3 stringent conditions to accommodate Beagle II. There was to be no ESA funding, the weight was limited to 69 kilograms, and it had to be ready in 3 years, a very short timescale. The race was on. Everybody else had started a year earlier in 1999. The satellite was already in build in Stevenage. So, could Beagle II be financed without any help from ESA? Could it be contained within 69 kilograms? And could it be completed in 3 years? A big challenge. However, these conditions were not going to stop Colin Pillinger. This is a story of his incredible endeavour, of his courageous effort against very difficult odds, and of the success he so very nearly achieved, as we shall see later. Beagle II was released onto the Martian surface in December 2003. We'll now show a short video to illustrate this process.
When something goes missing without a trace, it's usually pretty difficult to find. Now, put that thing on Mars, and well, it becomes virtually impossible. That's exactly the predicament the European Space Agency found itself in when the British landing spacecraft Beagle II went missing over a decade ago after being ejected from the mothership Mars Express. After traveling at speeds at 12,000 miles per hour, Beagle II was supposed to have landed on the surface of Mars on Christmas Day 2003, open up like a pocket watch, and begin to search for signs of life on Mars by studying the composition of the planet's soil and atmosphere. The plan was a robotic arm equipped with a bunch of tools, including a rock abrasion tool and a burrowing mole tool, would gather samples from the surface in search for biological signatures of life, like carbon-12 and methane. The craft weighed a mere 70 pounds and was supposed to have deployed a parachute and airbags to cushion its fall. But the craft never phoned home like it was supposed to, and the rumor mill started. Maybe it was destroyed on impact, the parachute didn't deploy. Perhaps even Martians shot it down with laser beams. Several attempts to track down the probe were unsuccessful, and it was deemed missing. But Beagle II, you're not alone. Over half of all missions to Mars have failed. They call it the Mars Curse.
Did you know that half the missions to Mars have failed? Some believe Mars is cursed. There have been 54 missions since 1960, 23 Russian, 23 American, 5 European, and 1 each for Japan, China, and India. And 24 of these missions have failed, half of all the missions to Mars. The latest failure was Schiaparelli in 2016. So, did Beagle II succumb to the curse of Mars? Now, how was Beagle II made without finance, at the required rate and on time? The driving force behind it all was Professor Colin Pillinger of the Open University. He was supported by 2 other key people, Professor Mark Sims, the mission manager of Leicester University, and Dr. Jim Clement, Chief Engineer at the Astrium Space Division in Stevenage. The first obstacle: no ESA funding. Colin Pillinger ran a very successful international lobbying campaign. He persuaded industries, bankers and media to support the venture with money and engineering contributions. So 50 engineering companies in the UK contributed to the design, build and test of hardware and software, etc. Universities provide the instruments and the sensors. The total industry and university contributions amounted to some £50 million, $65 million. Near the end, there was insufficient funds to complete the job, so the UK government was persuaded to provide the last £25 million. The second obstacle: of the 3 conditions, the weight limit proved the most challenging, 69 kilograms for everything. ESA were adamant on this. That's the weight of an average young person. The third obstacle was the short timescale. The normal schedule for a new space mission is at least 5 years. Beagle II had 3. Nothing could be done on this. It had to meet the deadline, or it would not fly. This did mean, however, things were done in a rush, some items could not be tested properly, and items were tested separately instead of together. The Colin Pillinger publicity campaign extended to other areas as well. The famous artist Damien Hirst painted a palette of colours. This was to check how the Martian atmosphere would distort any of the colours. The rock band Blur wrote the Beagle II theme song. In the end, the money was raised. Beagle ended up a few grams under the 69 kilograms, and it met the ridiculous schedule. All thanks to the incredible endeavours of Colin Pillinger and the other key members of the team. So, what were the objectives of the Beagle II probe? Beagle II was the first ultra-clean lander to look for life on Mars. 3 other spacecraft had landed on Mars, but their results were suspect due to possible contamination they had carried with them. Beagle II was there to check the composition of the atmosphere, evaluate the surface properties, make chemical analysis of the soil, looking for carbon, carbonates, methane and water. In other words, to look for evidence of life. Let's look at the makeup of Beagle II. At the top you can see the spin-up mechanism, and below that the back cover, then the parachutes, the airbags, and the lander, and finally the front heat shield. In 2002 it was realized that the parachute could be better. So a standard balloon type parachute was changed to a ring sail at the top, increasing the drag due to air turbulence. The parachute was made of the latest and lightest materials available. The airbags were made by a company called ILC Dover in the USA. Like everyone else, they were severely restricted on weight and volume. Their airbags were tested in a very tall vacuum chamber, and they had several failures and retests before success was achieved. They were at the limit of the materials that were available. The lander was so crowded, it required some ingenious engineering to pack it all in. The spectrometer, normally the size of an office desk, was shrunk to the size of a box of chocolates. The wiring was soldered in situ. There were no connectors to save weight. There was virtually no backup systems. This was unheard of in normal space missions. A very risky approach, but there was no other option. Beagle II made it to the launch site on time. Mars Express was launched on the 2nd of June 2003 on a Russian Soyuz launcher from Kazakhstan. The rocket made a double circuit of the Earth to take advantage of the Earth's gravitational effect. The journey took 7 months. It arrived into the Mars orbit on the 19th of December 2003. Once in orbit, Beagle II was released to touch down on the surface of Mars on Christmas Day 2003. Mars Express was tilted in orbit to send Beagle II off in the right direction. Too steep, and Beagle II would burn up in the atmosphere. Too shallow, and would bounce off into space. Beagle II was spun up to release it to give it directional stability. Beagle II was ejected with the heat shield at the front, and Mars Express was then tilted back to continue its orbit around Mars. Beagle II was ejected, flying through the atmosphere at 12,500 miles an hour, as fast as going around the world in 2 hours. The temperature of the heat shield would reach 1700 degrees centigrade, but the cork and carbon fiber insulation on the heat shield held the inside temperature below 35 degrees centigrade. The Martian atmospheric drag would reduce the probe speed to around 700 miles an hour. The parachute was then deployed, and the flight speed was reduced to 35 miles an hour. The airbags were then inflated and the parachute jettisoned. The airbags then cushioned the fall to the surface. The airbags were then released and dispersed. The lander fell to ground from a height of about 3 feet or a meter. Mars' gravity is less than half that of the Earth, so it's not such a heavy bump to the ground as you might think. The Martian atmosphere is nearly all carbon dioxide, 95%, and it's cold, down to minus 100 degrees centigrade. The atmosphere is very thin, only 10 millibar. That's 1/100th that of the Earth's atmosphere. The parachute redesign of 2002 made it bigger, better and lighter, however. Later it was found that the actual atmosphere could be even thinner, down to 6 millibar. There was virtually nothing for the parachute to hang on. So, could it or should it have been made even bigger? On landing, the lander opened like a clamshell, like a gent's pocket watch. So it did not matter which way up it landed. The 4 solar panels were then expected to deploy to expose the transmit and receive antenna. The antenna signal would go up to an orbiting US Mars satellite for transmission back to Earth. Inside the lander, you can see the red area, which is the battery and electronics, the gold area, which is the measuring sensors, the blue area, which houses the instrumentation electronics, the brown area, which is the science package, the green area, which is the robotic arm and the sensors, etc., and the yellow square, this is the transmit and receive antenna. Note that all 4 solar panels need to deploy to expose the transmit and receive antenna. This is the robotic arm, which compromises the mole with its jaw for soil collection, the stereo cameras, the rock grinder, as made by a Hong Kong dentist, the spectrometer, the gas analyzer, and the microscope. The mole was a burrowing tool used to collect soil samples for chemical analysis. The mole had an internal hammer action, which propelled it forward to a maximum travel of 1.5 meters, 7 feet, along the surface or down into the surface to collect soil in its jaws. This was then winched back to the science package for chemical analysis. The science package was the heart of the mission. It had the chemical gas analysis system, with ovens to heat soil samples from the mole. The resultant gases were then analysed for carbons, carbonates, methane and organics. Just checking for life on Mars. Beagle II had learned the lessons from 3 earlier landers. Everything had to be ultra clean and sterilised. Don't take your microbes with you. A super clean room was built at the Open University. Air was filtered to below 0.5 microns so that no microorganisms could be present. All items were sterilised to 120 degrees C before entering the clean room, including my friend Bob's walking stick. No one with colds or sneezes was allowed in. A sneeze generates some 300,000 microorganisms. All hair had to be covered up. Double clean clothes were essential. The first layer to avoid touching the outer clean layer. It took 20 minutes to get togged up. Touchdown of Beagle II was due at 3 o'clock in the morning on Christmas Day 2003. Beagle II would send a signal to London via the US Mars orbiting satellite at 6:30 a.m. The signal time to Earth from Mars was about 4 minutes. No signal was ever received, not a single peep. The battery capacity was 1 day only. There was no possibility of communicating with the lander, and the mission was assumed lost by February 2004. The effect was devastating. It was heartbreaking. One always hopes that the signal would eventually come, but it never did. Colin Pillinger had worked so long and so hard. He had convinced so many to help. He had put space into the public mind in the UK. His anguish was palpable. His life mission was unfulfilled. He died in 2014, a few months before Beagle II was found on the Martian surface. There was a long search for Beagle II from photos on Mars, but nothing was noticed for 11 years. The effort petered out. Then, in November 2014, a German scientist noticed a small white dot where Beagle II was supposed to have landed. It gave several clues of Beagle II. It was only 3 miles, 5 kilometers off the expected landing site. The plane is flat, there were no shadows. It was bright and reflective, unlike the surface on Mars. The shape was triangular. Were 2 panels missing? It was the right size, and there was evidence of the airbags and the parachute nearby. I will now show you a short video about finding Beagle II.
It was meant to find life on Mars, but when the space probe Beagle II lost contact on Christmas Day 2003, it left Colin Pillinger, the mastermind behind the project, devastated.
We did not get any content of a signal, nor indeed a signal from the surface of Mars.
Colin never did find out what happened to Beagle II. He passed away last year, but scientists have been trying to figure out what happened to it ever since, and now it looks as if they have. It might look like a small white dot to you and me, but this is proof that Beagle II did land on Mars. These new images, taken with a high-resolution camera by NASA's Mars Reconnaissance Orbiter, appear to show that not only did it land, it partially deployed.
I'm very excited that this is Beagle II. It's closure for me. Always wondered what happened to Beagle II. It looks like we've really found it on the surface of Mars.
Someone else involved in the project were the band Blur, who created a piece of music to be the probe's signal back to Earth when it landed. Dave Rowntree from the band told us that he'd always hoped they'd find it.
We do appear to have been inches away from a successful mission. It seems like the last panel didn't unfurl. We can't definitively say that yet, but if that's true, I mean, how heartbreaking, really.
But Colin Pillinger would have been thrilled that the entry and landing went to plan, and he'd have no doubt tried to improve upon the original model for future missions. Of course, the real tragedy of today is that Colin Pillinger isn't here to share it, because he'd always said that not knowing what happened to Beagle II was the worst part.
You can't help thinking that there's one person who's not in the room who would be the, he'd be very much the centre of attention. He'd be revelling in such an experience to be here. So it's sad from that side of things, certainly.
If Colin had known that we got so close, he would have immediately written another grant application to do a Beagle III. Nothing would have stopped him from doing that.
Colin always said we had unfinished business on Mars, but now it's going to be up to someone else to finish what he started. Ruth Liptrot, 5 News.
At the ESA inquiry after the failure, 3 main failure scenarios were considered. 1. Did Beagle II hit the atmosphere at the wrong angle? 2. Did the parachute and airbag cords get tangled together on landing? 3. Was the air thinner than expected? The answer to items 1 and 2 was no. It made it down to the surface and opened, partially. For item 3, the air was probably thinner than expected. So, was the parachute not big enough? Probably. Did it have a harder landing and did an airbag split? Did a hard landing damage one of the opening mechanisms? Here are some observations about the loss of Beagle II. Beagle II had a severe weight limit. This meant it was risky with no margins for error. However, it later transpired that the Mars Express had many kilograms of weight to spare. A few kilograms could have made all the difference to Beagle II. The schedule was so short that complete testing was not possible. The atmosphere was thinner than expected, giving it a higher descent rate, and it might have hit the ground too hard. Success needed 4 panels to deploy. Only 2 or 3 panels opened. In reality, It was a monumental achievement. Huge technical challenges were overcome. It was a marvel of microengineering. It captured the hearts and minds of the country. It did land on Mars, and the landing sequence worked. It was only a whisker away from success. It was a tragedy that not all the panels deployed. Someday, someone will examine it and tell us why. So, let's have a wish list. Don't you wish you could just get over there and open the last solar panel? We had more weight allowance since Mars Express had so much to spare. We could have made the parachute bigger. We could have made the airbag stronger. And we could have made the panels deploy differently. This is all very well in hindsight, but space is a hard taskmaster. There are no rooms for errors. We just have to learn the hard way. Moving on now, the next ESA mission to Mars was a joint Russian-ESA venture in 2016. It was to be a lander called Schiaparelli, weighing at 600 kilograms. It was to be a platform for future Mars missions by ESA. It had a very large parachute and retro rockets, clearly a lesson from Beagle II. The Schiaparelli module was launched in July 2016. All went well until the final few moments. The parachute deployed okay, but caused the module to spin. The spin of the module confused the software, so the retro rocket stopped firing 4 kilometers above the surface and the module crashed into the ground. Was this the Mars curse again? However, the Schiaparelli module will be fixed for future missions. The ExoMars rover, as shown, is due to fly on this module in 2020. The hopes of those from Beagle II will be carried on the ExoMars rover. We wish it bon voyage. However, there's been some startling news from the Mars Express satellite itself. Although launched in 2003, it has kept working. The subsurface ground-penetrating radar experiment, called MARSUS as you remember, showed the images of water on Mars in 2018. How extraordinary to find water using the original Mars Express satellite. The MARSUS radar software was updated in 2017 to be more accurate. A cross-section of the surface shows what appears to be liquid water about 1 mile, 1.5 kilometers below the surface. We now know that ice and mush water has been detected in rocks elsewhere on Mars. Colin Pillinger would have been delighted with these discoveries. Thank you.